Hello, grade 11s. Welcome back again. Today we are looking at your trigonometric functions. I know you're excited. This is the easiest part of mathematics and you like it so much. All right, we're just going to recap on the work that we did in grade 10. So I'm going to quickly give you some time to work on the following terminology. What do the following words or terms mean? Okay? Right, when you look at the period, amplitude, domain, and the range. So you've got a maximum of 3 minutes to discuss with your friend, and you're just coming up with the terminology and in your own words, what do these words mean? So I'm giving you 3 minutes. Let's work as a team, and then we'll continue from there. Right, grade 11, let's just check if we're discussing the correct things or we're talking WhatsApp or Facebook or Twitter and whatnot. Let's check if you've done the correct thing, all right? Now, with the terminology, going back to, first of all, your period, all right? The period is a number of degrees that the graph takes to complete one complete cycle, all right? Remember when you were in grade 10, you had a graph that looks like this, all right? Now, this is your parent graph of y equals to sine x, and it takes 360 degrees to complete a circle, all right? That's the same thing with cos as well, right? And then that's your y, then that's your x. And then with your tan, as we'll be looking along, it completes every cycle 180 degrees, right? And then we looked at the amplitude as well. The amplitude is the furthest the curve gets from its mean position, or the distance from the middle line to either the crest or the trough of the graph. Now, if we look at the very same example again, guys, this is the parent function. Okay, that's -1 and then 1. And then the distance from the middle to either the crest or the trough of the graph. Okay, so this is the highest point. So it means that the amplitude here is 1. Okay, and then now when you looked at your domain, remember we said the set of x values for which the graph is defined. And then your range, it's the set of y values for which the graph is defined as well. Okay, now we're going to be looking just briefly on your parent functions, which is your y equals to sine x, your y equals to cos x, and your y equals to tan x. And now, remember guys, all the transformations that we're going to be doing, they will be based on or starting from your mother functions, okay? Right, so you've got your y equals to sine x, right? As part of our revision, I want you to quickly look at the following, okay? The maximum value, the minimum value, the period of this graph, and the amplitude, okay? So as we are working, you're working with your friends, let's look at this graph. Just write the equation here. Y equals to sine x. I want you guys to find the maximum value, minimum value, the period, and as well as the amplitude. Okay, I'm giving you only 2 minutes. Please work on this activity. All right, let's go, 2 minutes. All right, guys, let's now check your maximum value. Going back to your graph, this is 1, even though it's not that clear. That's 1 there, that's -1. Okay? Now, this graph going below -1, all right? So you don't meet your graph. And then you're going above y equals to 1, you don't meet your graph. So it means that the maximum value for this graph is 1. So the maximum value is 1, and the minimum value is -1, right? And then now with your period, now we're looking at a graph y equals to sine x, right? Now, watch guys. Remember last year, you checked this is 1x, right? So, and remember we determined the period here. So the period of this graph is 360 degrees. And now, if you still remember from grade 10, that if I have, for instance, sine of 2x, the period of this graph will be your 360 divided by 2, which is now equals to 180 degrees. But if you had sine half x, right, that will be your 360 divided by half, which gives us 720. So your period is going to be 720 for that one. All right. Now, your amplitude, again, guys, if I've got y equals to sine x, then this is y equals to 3 sine x. This is 1 sine x. Our amplitude from last year, for this particular graph is 1. But if I've got the y equals to 3 sine x, so it means that your amplitude will be 3. Okay, right. I hope this helps. Now let's move on to the next problem. Okay, right. You've got the cosine function, y equals to cos x. You need to work out, just like we did before, the maximum value, minimum value, the period of this graph, and your amplitude. Again, guys, you've got 2 minutes, and then we can discuss it. All right, let's go. All right, guys, let's just check quickly. Like the previous graph, this is 1, and then this is your -1. We'll quickly do this one. What's your maximum value? Like we did, this is 1, and then the minimum value will be your -1. And your period, Again, we're looking at this graph, y equals to cos x, right? So it's cos 1x. So our period here is 360 degrees. It's going to repeat every after 360 degrees, right? So you see that it completes a cycle in every after 360 degrees. And then your amplitude, and as we said, this is y equals to k cos x, and that's your amplitude. And in this case, it is 1. So you've got your amplitude as 1. Okay, guys, we're going to take a short break, go get some water, and then we're going to continue with your trig functions. Right, let's go drink water. Welcome back, guys. I'm sure you've had some juice, water, or snacks and Coke or something. We're back with our trigonometric functions. All right, so we've got the tangent function, which is your y equals to tan x. All right. Now, as you are refreshed, again, when you are drawing your mother function for a tan graph, it is important to specify this point, which is your 45 and 1. Remember, if x is 45 degrees, substituting that in the place of x, you get y equals to tan 45. That is a special angle, so tan 45 is 1, right? So where it caps, and also for negative 45. And remember, this is the graph that has got asymptotes. It is asymptotic, negative 90, negative 270, and then 90 and 270. We'll do the same with this graph as well. You quickly do the 2 minutes. You are hands-on with this exercise. So you quickly work with your friend. You find, like we were saying earlier on, the maximum value, minimum value, the period of this graph, and the amplitude. Okay, 2 minutes, guys. Let's go. All right, guys, let's see. From the two graphs, your y equals to sine x and your y equals to cos x, it was very clear when you were looking at your graph minus 1 and 1. But I'm looking at this graph, I don't see the y value, and you can see that this graph continues it continues there, all right? So what is going to be your minimum value? You are starting from negative infinity, all right? So this is minus infinity. And then it continues on and on again on that other side. Your maximum value will be positive infinity, okay? Right? And then now you look at your period, okay? Right, this graph is going to repeat every after 180 degrees. So your period here is 180 degrees, and then your amplitude, remember what we said, right? This will be your tan x, it's 1 tan x, okay? So your amplitude is 1. There are things that are common with these parent functions, okay? Right, now if we look at our key concepts here. The effect of multiplying a function by a, okay, all right, this is a vertical stretch or compression of the function. The value is, the a value is the amplitude of your trig graph, okay? So for instance, I've got y equals to 3 sine x, right? That is your value of the amplitude as we've been revising. Okay, now if your a is greater than 1, then the graph is enlarged or stretched vertically, right? Your graph started as y equals to sine x, right? Now, if I want to draw this graph, this is minus 1 and then 1. But now if I have y equals to 3 sine x, now my highest value will be 3. Let's say 3 is there, and then down there is minus 3. I still have the same graph, but the only difference is that this graph has been enlarged, okay? And then now, if a is less than 1, the graph is compressed, okay? And the x value remain unchanged. Let's look at these two examples, all right? This is your y equals to 2 sine x. Now, if you look at that, you've got a 2. The initial graph was y equals to sine x. So what has happened to your graph? The amplitude changed from 1 to being 2. It's the very same graph of y equals to positive sine x, which is that graph. But now the highest peak will be at 2, all right? And then the y equals to minus sine x, right? This is the very same graph, but now you flipped it. So you've got y equals to negative sine x there. Okay. Now what about the effect of adding a q in that graph, right? You've got y equals to sine x. Now I have y equals to sine x plus 1. What has happened to the graph of y equals to sine x if you are adding a 1, right? Like you were doing with in your parabola, straight line, your hyperbola, and so forth. What happens if you add a 1? You are pulling the graph 1 unit up, all right? So you had a normal graph. Let's just use a different color, okay? You have, this is y equals to positive sine x. Now, what is happening is that now I am adding a 1. So wait, this was 0 and 0. So you are pulling the graph up 1 unit up, all right? And then where there was 90 and 1, so this one is now added to, so it's 1 plus 1, which is a 1. And then this was 0, the point goes up to 180 and 1, okay? And then you've got a graph that is being pulled 1 unit up. And then what happens if you subtract a 1? It's the very same graph, but you are taking it down 1 unit, okay? So it's up and down. I'm adding a 2. It's going to be 2 units up, okay? I'm subtracting a 2, you're pulling it down 2 units. So the graph is shifted up if q is greater than 0, is shifted down if q is less than 0, as we can see in our example here. Okay, right. So now, the next part, you need to draw a sketch graph of y equals to 2 sine theta minus 1, and your theta is from 0 degrees to 360 degrees. Now, what I want you to do, guys, is you busy sitting with a friend and you are discussing about this graph. I want you to start with a parent function, y equals to sine x. You do all these transformations, and at the end of the day, you get a graph of y equals to 2 sine theta minus 1. So you start from y equals to sine theta. You've got 3 minutes to work on this graph, and you're doing all these transformation together with a friend. All right, guys, let's go. 3 minutes. All right, boys and girls, let's just check. You've got y equals to 2 sine theta minus 1. And then as we are saying, we need to start from the parent function, y equals to sine x. Okay, now this is our Cartesian plane. All right, starting from 0 to 360, you've got 90 degrees, 180 degrees, 270, and then 360. Okay? This is 1, and then you've got minus 1. There's 2, and then there's minus 2. All right. Your normal graph of sine, 0 and 0, 90 and 1, 180 and 0, minus 270 and minus 1, and then you've got, let's change these points. No, sorry. This is a normal sine graph. Now, so we've done only that part. Now, what happens now if I'm including now a 2, which is your amplitude? So I'm pulling the very same graph up, okay, to your amplitude is now 2. All right, so it means that this point is here, that point is still there, and then this one comes here, and then that is there. So then that is your graph, okay? And then now what happens if you're now adding a minus 1? So it means that you are pulling the graph 1 down. So this point comes here, and then that is there, and then this, and on. It's just going to be complicated here. Let's just check if you've got the correct graph now. So you see that point was now up there. I'm taking it down 1 unit. So you've got, it's your minus 1, and then the 180 and negative 1. So if you've got something like this, that is correct. Now, remember, guys, this was a normal graph of sine. It was up to 2, then you drag it down 1 unit. So to those of you who've got it right, well done. We need to move on to the next part. Let's go for break for now, and then when you come back, we'll continue with these problems. All right, welcome back, guys. I'm sure you guys are working very hard. You're taking notes, and you keep on doing practice. As maths is not a subject where you need to sit down, you chill, you watch other people doing it. You have to be hands-on, and that's why we're giving you some activities. You do them yourselves, and from there we check if we're doing the correct thing. All right. Now, remember what you used to be doing last year when you were drawing these graphs. You'll put them on a table format, and then you plugging in the values, minus 360, minus 270, minus 180, and so forth, depending on your restriction, your domain, and so forth. All right? Now, those of us who are struggling with maybe drawing the trigonometry graphs, what you need to do is to go back to the table format, just to check if you are doing the right thing. All these transformations that we've been going on about. You take the graph as it is, you go to the table mode, and then you go to 3, and then you type in your function as it is, your minus cos theta plus 1, and then you tell the calculator where to start and where to end, and the spacing and so forth. And then you'll be checking your values, the x corresponding to y and so forth. And then you take those values, you play around, and then you draw those graphs. The next problem, I want you to do the same. It's either you take your calculator and you work with your table and so forth, or the one that I wanted you guys to just focus on is to take the function cos x, apply all these transformations up until you get y equals to negative cos theta plus 1, where your theta is from 0 degrees to 360 degrees, right? So now let's go. I'm giving you 3 minutes to take y equals to cos x, transform it up until you get it to y equals to negative cos x plus 1. Where you are sitting, you need to show me the graph of y equals to cos x. Need to show the graph of y equals to negative cos x, and adding a 1, what happens to your graph? Okay, now let's take the 3 minutes. Let's work on this one. All right, guys, asibone. You've got y equals to minus, my line is not as a straight line, okay? Nevertheless, this is y, and that is your x. From 0 to 360, okay? 90, that's your 0 degrees, 180, 270, and then 360, and then you've got a 1, and then a minus 1. Guys, as we have agreed earlier, that we start from the normal graph of cos. And now remember, when you are pressing your calculator, when x is 0, y is 1 for cos, okay? Iban. It's colorful. All right, so 0 and 1, and then where is this? This is your graph of cos, right? Remember, 0 and 1, 90 and 0, 180 and minus 1, and so forth. So we'll quickly do that, right? And that sub to 360, then your graph should look like this. And it's now reflected. Okay, so you now have y equals to negative cos x or negative cos theta. So it means that this is now here, right? And then that is there. And then this point, 180 and 1, so now it's going to be 180 and negative 1, right? And then your 270 and 0, the 360 and minus 1. Then we have a graph that looks like this. Now, let's now just check with your +1 what is happening. You are now pulling up the graph, which is negative cos theta, by 1 unit up. So it means that this point goes up 1 unit, okay? And then that goes up 1 unit. And then this one is 1 up. And which other one? It's 1 up. And then this one, it's 1 up as well. Now let's trace these points. So it means that I am going to have a graph that looks, like that. There's a point that I'm missing, okay? So this one went up, so you've got a graph like that, okay? So you are pulling that graph up. So your graph looks like there's a point that I'm missing there, okay? Right, 1 unit up. Just checking again, you have, your graph was 0 and 1, 90 degrees and 0, and then 180 and minus 1, and then this, and then up to there. So this was your normal graph, okay? And then what happened is you then flip it. You now have your graph here, which is now going the other direction. What is happening with this thing, okay? So your graph now looked like that, okay? And then when you were taking it up, +1, so your graph is here, and your 2 is up there, all right? And then there's this point should be going up. So it means that we have this, and then it should be going down there. So you've got a graph that looks like that. Okay, now guys, quickly, the next part, you need to draw a sketch graph of y equals to 2 tan x minus 1. Same thing, you apply these transformations. You start with y equals to tan x, and then from there you've got y equals to 2 tan x, and then minus 1. But now the difference here, you're starting from negative 360 to positive 360. Okay, guys, let's take 2 minutes, and then we look at this tan graph. Let's go. Let's help each other. You've got y equals to 2 tan x minus 1, 2 minutes. All right, guys, let's check if you've done the correct one. Let's look at our tan graph. Remember, we said it's going to be, now, your tan graph, your y equals to positive tan graph, it passes through the origin, right? And then it's asymptotic at 90 degrees and your 270. And then it's 45 and 1. So your graph should be looking like this. And this side should be cutting there. Now, it's now up to 2, so it's 2 tan x minus 1, and then you're pulling it down negative, you're pulling it down 1 unit. So you get that graph, which is represented by the red here. Okay. Now, next, what they can do, again, remember last year what you were doing, is sometimes you get a graph to draw, or they draw a graph for you, and then you have to give the equation for that particular graph. Now, if in this problem, you need to determine the equation of the following graph, okay? Right. I was going to give you some time to work on this graph, but because there is no time at all, let's just look at this graph. It looks like a sine graph. But if you were to draw your cos graph, right? Now, starting with your sine graph, this is 0 and 0, 90 and 1, and then 180 and 0, and then 270 and minus 1, and 360 and 0. Now, guys, just giving you a hint, you can work from this graph to determine the equation of the graph that is given to you. Now, remember in grade 10, but because of time, we're not going to be able to do it, but we're hoping to do it the next lesson. But from me, I'm going to say goodbye to you guys and good luck with your trig graphs. See you next time.